Hello folks, welcome to today's video. This will be the first video in the next unit, which is circle geometry. And today's video will just be a review of some of the skills that we have previously learned that we need going into this unit. This unit is an interesting one. It's one of the very few times we'll actually take a look at circle geometry in your high school math career. But it is quite a cool little unit because what we end up learning is that when we start looking at circles, there's certain properties that end up developing that make it that we're able to solve problems maybe we weren't able to solve before, because when we start adding lines and things to circles, we end up finding that they have some really interesting properties going on. Okay, so before we do, let's talk some shared vocabulary here. So the first thing that we want to talk about is our three kind of parts of a circle. So part number one is the circumference, right? Your circumference of your circle. And we would describe the circumference as the distance around the circle. Or in other words, if I wanted to take a circle and tie a piece of string so that it wrapped all the way around that circle, right? The length of that string would be my circumference. Okay. Property number two is the radius, right? The radius is a line that if we were to start at the center of the circle and draw out to an edge of my circle, we would call that line the radius. And I could draw that line anywhere around my circle. I could draw it there, or I could draw it there, or I could draw it down here, whatever. These are all known as radii, and each of these radii would have equal lengths. Okay, and then the following, or the final property or terminology we should know, is the diameter. And again, a diameter is similar to the radii, but it's two radii. Okay, the diameter has to go from an edge of the circle to another edge of the circle, but pass through the center. And much like the radius, the diameter, no matter where I draw it, will always be the same length. So there's a diameter there's a diameter there, and all three of these lines would have the same length. Okay, so really quickly, before we get into circle geometry, let's just do a really brief review of the Pythagorean theorem, because we're going to need it here in a second. So the Pythagorean theorem says that a squared plus b squared is equal to c squared, where the legs of my triangle, the side lengths that are adjacent or beside that 90 degrees, are a and b, and the third side of my triangle, the one that is right across from that 90 degrees, is c, and that c has a special name. That name is the hypotenuse. Okay, so what we can do with the Pythagorean theorem, which we've already seen in this course, but we'll take a look at again, is we can find the value of a missing side inside of a right angle triangle by using this formula. So here we would have 4 squared plus 6 squared is equal to c squared, or in other words, 16 plus 36 is equal to c squared, or 52 is equal to c squared. Now, this side length right here is c, not c squared. So in order to find the length of c, what we need to do is take the square root of 52. And if we think back to taking the estimations of square roots, that's about 7.2, give or take. If you wanted to grab a calculator and check that, you're more than welcome to. Okay, so what we'd say is that side length c here is about 7.2 units long. Okay, but we can also use our formula kind of rearranged as well. So something about the hypotenuse. The hypotenuse will always be the larger side in a right-angled triangle, right? So in this triangle here, it was 7.2, which is larger than both 4 or 6. In this triangle here, it's going to be 13, which is going to be larger than those two sides. So because of that, we find our hypotenuse by adding the squares of the other two sides. Now, if I wanted to find one of the other two sides, what I need to do is I need to subtract from my hypotenuse. Okay, so instead of adding to find the hypotenuse, I'm going to subtract from the hypotenuse to find one of the other two sides. So if I wanted to find a squared here, it would be 13 squared minus 12 squared. Okay, so in this case, a squared is going to be 169 minus 144, which is 25. So then a is going to be equal to the square root of 25, which is 5. Okay, so just a quick brief review there of the Pythagorean theorem. Okay. Now, there is another property about triangles that we should know going forward, if you weren't already aware. But if I were to take the three angles inside of a triangle, so 45 and 103 and 32, and if I were to add those up, I end up getting 180 degrees. And if I were to look at this triangle over here and add up these angles as well, so 65 plus 90 plus 25, I get 180 degrees. And this is not a coincidence. If I were to look at the angles inside of a triangle and add them up, I always get 180 degrees. Now, why do we care? Well, the first thing that we would be able to do with that information is if I did not know the value of that angle right there and I wanted to find it, I could use this backwards. I could say, well, if I know that these three angles are supposed to add up to give me 180, then what would happen if I took 180 and I subtracted it by the other angles? Well, that would leave me with 32, which would be the value of my missing angle. Okay, so really important that we know how to do that so that way we can find these missing angles and we can make some key points about a triangle. Okay, so this was just a brief little review about triangles and about the Pythagorean theorem. We're going to leave it here for today, and in the next video, we'll look at what's called a line of a tangent line and a point of tangency, and we'll look at how we work with those. Okay, so that's it for today, and I will see you all in the next video.